lesson 8 is writing linear equations, pretty much what we've been doing, but this time it's going to be dealing with two variables. You've been changing equations with two variables, but you haven't been solving for them. So, again, another example, one that we're going to see all the time is y equals mx plus b, slope-intercept form. Okay, you should be used to seeing this by now, but I want to remind you that just because it sounds like a new concept doesn't necessarily mean it's all new. Okay, so y equals mx plus b is a two-variable equation, one at which we will solve for. The two variables here are y and x. M and b stand for something. M stands for slope, and b stands for the intercept. So those aren't variables here. They actually end up going in as something. Emmett, will you flip off one of my switches so that the front is a little bit darker? Thank you, sir. So, as an example, y equals 50x, 50x is what I meant to write down, 50x is an example of a two-variable equation. And they might give you something that says, solve this for when x is 4. And you'll just do that. You'll plug it in. So, y equals 50 times 4. Simple enough. We know now that y is equal to 200. Okay, so the beginning steps of this is actually how you check the answer if you actually needed to solve this, but you need to know substitution. Alright, y equals mx plus b is going to be the most important thing that we're going to use in this section. So know this equation, know that m stands for slope, or rise over run. Okay, if you don't know rise over run, go ahead and write her in. Okay, and the y-intercept looks something to the effect of 0, comma, whatever the y-intercept is. So 0, comma, b. It's just where it crosses the y-axis is all. Okay, let's go to this next page. We're just going to start in on some examples. A botanist transplanted a plant that was 3 centimeters tall into an experimental soil. He took measurements once a week and found that on average the growth rate was 0.5 centimeters per week. Write a linear equation of two variables to describe the height of the plant over time, and then graph that equation. We're going to end up graphing quite a bit here, so if you want to do your homework on graph paper, or if you have graph paper and want to do part of your homework on it, I highly encourage you to do that, because you will need it to make yourself look at least halfway neat and organized. If I can't tell by your graph what you are graphing, then it's not neat enough, okay? So if you already know you have bad handwriting, graph paper should be your friend here, okay? All right, so on y equals mx plus b, another way to see this. M is your slope, your rise over run, your rate of change, okay? Your rate of change, that's what you should probably get used to. And b is your y-intercept, your 0, comma, b, but it is also whatever you started with. It is your initial, I'm not going to put anything else after that, it's just your initial whatever. So in this case, it'll be its initial height, which was 3 inches. Okay, so when I start this equation, I'm going to say y, because y, and then I put in my rate. My rate was 0.5 centimeters per week. X, I'm always just writing down my variable, plus whatever my initial was. My initial was 3. Okay, so there's my equation. I find it a lot easier to graph things when they're in fractional form because it tells me rise over run, right? So my slope, my m, was 0.5. I find it easier, we all know this one, but just in case you get a number you don't know, I find it a lot easier to write something in fractional form. So I'll press this button, it'll say math. Okay, well, first make sure it's on. You'll hit math fraction. Okay, that'll change any number you put in to a decimal. It'll be math fraction. So this one is 0.5. So I put in 0.5, I press math, I hit fraction, and it'll convert that to a fraction for me. It's 1/2. We should already have known that. But in the event that you get something a little bit harder, like 0.3875, and you want that as a fraction, that's a little bit harder to do, but it'll do it for you, 31/80. Okay? So just to work a little bit faster there, that'll help you. So I want you to get in the habit of writing at least y equals mx plus b equations as fractions because they're a lot easier to deal with. So I'm just rewriting this now with 1/2 in for my 0.5. Remember that slope is always rise over run. Okay, my rate is easier read as rise over run. Okay, I'm going to zoom in a little bit right here. Remembering my equation, y equals 1/2 x plus 3. I'm going to graph this first. Okay, I'm going to graph this first. So it crosses the y-axis at 1, 2, 3. I'm just going to put a dot right there. Put a dot at 3 on the y-axis. Next, I go rise 1. So I rise 1 and I run 2. I put another dot. Easy peasy lemon squeezy, and I graph it by connecting the dots. If you want a third dot, which I highly suggest you do, you just go up 1, over 2 more, put your dot, and then you can connect all 3.
Will you move the picture to the right? Okay. Wait, right.
I don't have another right.
So I can see them.
Side note, this is going in second. Okay, rise over run. All right, so I need to quickly identify the things that I'm looking for on your lines. Okay, first of all, I'm going to look for at least 2 points. I highly encourage 3 just to verify yourself, but I need at least 2 points to make a line. Secondly, these arrows are not options. You have to have arrows to make lines. So no arrows, no line. Now, in the event that your equation doesn't call for negatives, which this one would not, right? I would accept you to start a dot where it would be 0 or where it started and go on forever in one direction. But that's only if negatives are not part of this equation, okay? Which it should not be. Negatives don't work with plants. Don't. You don't have... yeah, but... think about what x represents. X represents weeks, right? Can you have a negative number of weeks? No. How about negative height? Can you have a negative height? No. So, in this case, it would not make sense. Cool? Well, I'm sure you bury the seed, but its height isn't negative. It's just under the ground. Could go upside down, but that doesn't change its height. If I flip you upside down, Will, are you any less tall? Let's find out.
No, I don't think so.
That'd be fun. All right, guys. Let's go on to defining our variables here. Okay. We already know our rate of change. We knew our initial. But what does x stand for? When I plug in something for x, so if I said it grew 1/2 centimeter per week, what does x stand for? Weeks, right? So I need to define that. I need to say x is weeks. Sorry, that's 2 lines, but you can't really see it up there. And y then, if I was to plug in, let's say 2 for my weeks, 1/2 times 2, 2 times 1/2 is 1, plus 3 is 4. What would 4 be in this case? Because y is our what? Y is going to stand for our what? Height. Right? Our overall height after however many weeks. We have to be able to define our variables. We can't just randomly set variables without knowing what they are. Alrighty. It's pretty easy to find out what y is if you consider what your b is. If b was your height, then y is going to be your height. Okay? Almost always. Alright, so there's our equation. That's everything we're going to need. I said already that nothing in the negative is really going to matter here, so this part of our graph is pretty well useless. Okay? But from here to the right has to have that arrow. Alright, so let's go to another equation. The reason that graphs are nice is because you can look at them, but the reason equations are nice is because I want to know if we can continue at a steady rate, how big this thing will be in a year. I would just plug in 52, because 52 weeks are in a year, and I can find that out, and it's a lot easier to find that out plugging it in than it is to try graphing 52 weeks on a graph. Okay? Alright, let's go to the next one. Remembering always that if it gives us something to do with rate of change, it's probably going to fall into this format, y equals mx plus b. I want to look for my rate of change, my slope, my rise over run, all the same thing, and I want to look for something that's initial, something I started with. All right, so as I read this, let's see if we can identify our slope and our y-intercept. Tommy has 200 flyers to hand out. He hands out an average of 15 flyers every hour. Write an equation to model this situation. He says B might be 200. Does anybody agree with him? I see some shaking heads and then I heard him no. Why not? Oh, okay. Not good enough reason. I agree with him. It's what we started out with, right? 200 flyers is what we started out with. So I'm going to write it down. It's my initial. Then I need to find a rate of change, a slope, a something. 15. He says minus 15. Why minus 15? Because he's giving them away. We are taking away, so we have to have a negative there. Okay. Yes. So I'm going to plug them in so I can see my equation. I'm literally copy and paste. More than half of Algebra 1 is copy and paste. Alright, so from here, it says write and graph an equation to model this situation. Okay, this time I'm just going to go ahead and draw it. Am I going to have any negatives here at any point? No, right? So I know that I can stay in quadrant 1 of my graph. Meaning this can be my y-axis, this can be my x-axis. Because I know that I'm never going to have a negative. I'm never going to have a negative amount of flyers, or a negative number handed out, or negative time. So I know that I'm going to stay in quadrant 1. I'm just going to make that little corner right there. Alright. Let's identify what x and y are now. This said that he's going to hand them out 15 per what? 15 an hour? Okay, so x stands for? Hours. And our y is going to be our what? How many flyers he gave away, or how many he has left? That's what I want to know. So how many he has left. So remaining flyers. Ooh, I needed to make that just a little bit smaller. Alright, so we're modeling this situation. We're going to do a graph. Remember that your origin is always 0, 0. Okay? So we're starting at 0 and we're going to go up to what on my y-axis? Keeping in mind we have to start at 200. So we're going to go up to, are we going down from 200 or up from 200? Well, if we're going down from 200, we can start up here at 200 and go down. But if we're starting at 200 and going up, we need to put them down lower, right? So we're starting right up here. We need to decide what our increments are going to be. What is the increment of our graph going to be if we got to go all the way up to 200? He says 50. Keeping in mind that our rate of change is 15, do you want to go up by 50? He says 25. 20s. I think 15. Okay, so 25 was next, sorry.
15
We can go to something different than 200. I'm just telling you that's our destination. We have to get to at least 200.
Let's just do one.
Holy moly, no, not ones. No, we're not going to do ones. 20? Any disagreement on 20? If it's 20, how many marks am I going to have from 0 to 200?
5. Wait, no.
10. So I need to evenly distribute out 10 of my marks, right? it's going to be 20. So let's go up. 20, 40, 60, 80, 100, 20, 40, 60, 80, 100. So I'm just going to need to move that mark. And then label them. So get working on your graphs. Make 10 of your marks and then label them. Try to make them as evenly spaced as possible. Okay, I need to label that axis as well. What should we label it? What does Y stand for, guys? So what should we label that axis? Genius. Let's do it. Remaining flyers. And Cambry just had a stroke of genius. X stands for hours, so we should probably just go ahead and label that baby hours. Well, probably put the capital letter on the title, huh? Alright, how many hours do you guesstimate? Keep in mind we're just guessing here. How many hours do you think it'll take him to get rid of 200 flyers? How long do you think he'll get? He's going to need more than 10, right? Is it going to be less than 15? He thinks it's going to be around 13 hours, so would it be okay if we labeled our hours up to 15? You want to go by ones? I want to go by ones. Alright, you need 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Make sure you label.
How many?
They think that's going to take 13, so we're going to label 15 of them. We'll see how close they were to right here in a second. I'm going to graph it. Alright, we got a pretty good looking graph here. Just so you know, as a general rule, guys, anything that's going to be smaller than 20, you should probably just go ahead and make tick marks for each one. They're small enough that you should just go ahead and do it. Alright, so we need to start at what? We need to put a dot where? Keeping in mind our equation is y equals negative 15x plus 200. So we start at 200. I'm going to mark it. Boom, there it is. And then we need to go down, what? 15. And over 1. So down 15 is going to put me halfway between the half. And over 1 is going to put me right there. Dicey, tell me wait one more time, man. What am I waiting for? Tell me that.
Wait.
Landry would do that to me last year. She'd say wait, and then she'd stare at it for about 2 seconds. Okay, go ahead. Like, oh, okay. She never asked me a question, not one time. Alright, so then I need to do what? To go to the next one. Down 15 over 1. So I'd go down 15 more over 1, and I should create pretty much a straight line. So to make the most accurate graph as possible, it would have been smarter to go 15s, right? If we didn't want to do that, which we didn't in this case, y'all chose to go up by 20s, then we need to find something that's going to be a number close to a multiple of 20, because it'll make my lines a lot smoother. So he says 5. What's 5 times 15? 5 times 15? It's what? He says 75, so I could take 200 and subtract 75, and that would give me 125, but that's not an increment of 20, right? So it doesn't help us. How about 10? We know what 10 is, right? It'll give us 50, still not an increment of 20. You said 93. That one's going to be way too many. We don't have to have it perfect. Let's draw a line. Let's see how good our graphs are. We're all going to have different answers, so I want you to look at each other's graphs. You guys told me you thought it was going to be around 13. According to my graph, it's closer to 14. But I drew this graph by hand. We have to take in the element of human error. So this is why I don't like graphs. We're about to see why. Each group, I want you to come to a consensus on how long it's going to take him to hand out all the flyers according to your graphs. According to your graph. Go. All right, we're going to analyze this. We're going to see what our answers are and how much different they are according to our graphs. Okay? We all should know that the answer is about 13 1/3. That's the real answer. Okay? Now we need to find out what our graph said that the answers might be. So my graph said 14 hours. Maybe a little more than 14 hours, what it said. Group 1. You got 14, same? Group 2?
13.
I got 13.
14.
Got 14. 4. Got 13. Did any of us get the right answer? No, of course not, right? We drew this graph. Of course we're going to have some human error in this. Now I want to show you the difference if I would have just done 2 dots. Look at the difference that I could have made just looking at this, okay? My line would have crossed at like 12 1/2. If I would have just slightly moved my dot down right there and not connected to a third one, my graph would have been dramatically different. Even if I would have moved it just a little bit higher and got 13, look at the difference in my dots. There's hardly any, okay? So graphing is not the most accurate way to find an answer. I will give you a benefit of the doubt. Most of the time if they say use a graph, I'll give you a leeway of some sort. But whenever it asks for an exact answer, graphing will not be the way that we find it, okay? So on this one we found 2 different answers. We got 13 and 14. Neither one of those was correct. We're going to see how to find the right answer given the information that we were given. So we want to find out when he's done, right? So how many will he have remaining when he is done? 0, right? So I'm going to plug in remaining flyers, 0. Is negative 15x plus 200. And this, I know this is a little bit longer than the common sense way, but if we can solve the easy ones, then we'll be able to do the hard ones later. All right, what do I got to do to get x by itself? Order of operations backwards, right? So what do I got to get rid of? I got to get rid of that 200. How do I do it? I subtract it because it's currently being added, right? Guys, when I want to move a whole term, in other words, something that is being separated by a plus or a minus, I subtract or add it every single time. I told y'all that Thursday. I think we need to write it down. Write it down. When I want to move whole terms, add or subtract them. To move a term, you have to add or subtract it. Okay, there's no multiplication or division when moving a term. Whole terms always get added or subtracted. And here's another rule of thumb. You will never, ever, ever, ever move the variable that you want to isolate. It will stay where it's at. That's the whole point. Okay, if we want to isolate a variable, we're going to leave him over here. We're going to isolate him. We're going to leave him alone. And we're going to move everybody else away. All right, so I subtracted 200 to both sides. I got negative 200 on the left, and all I'm left with is negative 15x on the right. How do I get rid of a negative 15x? Multiplied by, right? It's multiplied by?
Divide.
I would have to divide. What I do to one side, I must do to the other. Remember that every time you do something to both sides, there was a point behind it, and it was for something else to cancel out. It's a bunch of copy and paste. So of course I get x on the right, and negative 200 divided by a negative 15 is going to give me a positive answer. 13.333333333333 repeating. Okay? X is what? Look up here, there's a key. X is hours, so it needs a label of hours. Okay, so 13 hours is our answer for that particular question that I just asked. Alrighty, ladies and gentlemen, we are moving on. I just want to rediscuss why this has limitations. Why can I not go over here with my line? Why can't I go to the left of my y-axis? What would the first number you'd see on this side of the... You'd see a negative. Can you have a negative amount of hours? No. Why can't I have a line that goes past 14 on the bottom side of x? Can I have a negative amount of flyers? No. So when I draw my line, it has limitations. It stops where the negatives begin, right? So it would go from here to wherever the first negative would be. Cool. All right. Moving on. This is example B, next page if you're not already there. See if we can figure out how to write this down. This is y equals mx plus b. We're still using that kind of format. But you're going to see it in standard form. So y equals mx plus b is the same, just isolated with the y. But you're going to see also things in ax plus by equals c. Okay? So a, b, and c are just coefficients. I use the word coefficient, but I mean what, Wes? What? What are coefficients? Coefficients are not variables, they are numbers. Right? So coefficients are really just the numbers in front of the variables. The variables are still x and y. There are going to be numbers in this equation. So let's do one for an example. A website sells MP3 downloads of music albums for $10 and Blu-ray movies for $30. Goodness. Fiona wants to buy some albums and some movies. She plans to spend a total of $150. Write an equation. So completely ignoring this, we're going to use x and y for our variables. What is x going to stand for? Albums. Albums, okay, cool. X is albums. What about y? So these are basically DVDs, Blu-ray discs. Alright, so I've established what x and y are going to stand for. She's going to spend a total, everybody knows that total means I need to write the equal sign, of $150. Now, how many, it says, write and graph an equation to solve for these. So, how many of each am I going to sell is basically the question.
She could buy 15 movies.
She could buy only 15 movies if she she could buy 5 movies only, or she could buy 15 albums. But the equation needs to incorporate if she buys a mixture, right? So if she bought some albums at $10 a piece, and she bought some Blu-rays at $30 a piece, then she would have spent $150. Everybody see kind of where that equation comes in, Ashley? Ashley? Do we see where that equation came from? Please explain it to us. 10 stands for what? Please pay attention so that you're not lost. 10 is the amount of dollars that I'm spending on albums. What is 30? It's the amount that we're spending on the DVDs. So X stands for number of albums. Y stands for number of Blu-ray discs. 150 is the total amount she's going to spend. So if we're going to graph this, there's multiple different ways to do it. I think one way is easier than the other. Again, are we going to need a full graph like that? All 4 quadrants? No. Can we have a negative amount of anything? Never, never, never when we're dealing with objects, right? So, I can deal with just one coordinate. I'm going to deal with the, well, it'd be nice if I use a straight line here. Work smart, not hard. Okay, so all I need is quadrant 1. So there's my quadrant 1. My X stands for number of albums, right? So I'm going to write that in as my title, number of albums. my y-axis is going to be number of Blu-ray discs. So number of Blu-rays. I don't even know how to spell Blu-rays. Okay, if I was going to make a big title for this, what would I put? If I'm going to put a big title on this, what am I going to put? What?
That's the total.
It's going to be the total number of money, or money spent, right? Things purchased, basically, is what it would be. Okay? We're just practicing it. You don't actually have to put something down. It's just things purchased. All right. If we established, because we kind of talked about it, right? Colton was saying how many albums she could buy total. How many albums could she buy total?
15.
She could buy 15 albums total, right? So on my number of albums, I need to go to at least 15. Just doing some simple math. Or we can go to 16, we can go to 20, we can go to higher, but we need to go at least 15. That means greater than or equal to 15. All right, how about the number of Blu-rays? How many can she buy?
1.
She can buy 5. So we need to go to at least 5. These increments are small enough that I should just mark them off. 1, 2, 3, 4, 5. If you're lazy like me, guys, and I know you are, don't write the number for every one of them. Okay, just do an increment and write in that number. But you can do a mark for each one, and then just write the number for each. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there you go. And then number of Blu-rays, that one's pretty simple. We might as well mark each one of those. 1, 2, 3, 4, 5. Alrighty. Colton got to the point. He gave me exactly what I needed. He told me how many of each one he could have. Now, the question is how he found it. So I'm going to show you a mathematical representation, because I know he just, common sense tells him, if I take that number and divide it, it'll tell me how many I can get if I just bought one thing. So let me show you what it is. I'll tell you to make an X and Y chart, and I'll tell you to stagger your zeros and find the other variable. This is exactly what Colton did, but he did it in his head. Let me show you what I mean. If I let X be 0, and I solve for my Y, I'm going to get a number. Okay, so let's do it. If X is 0, 10 times X is gone. It'll now be 0. And then I'm looking at 30Y equals 5. So I'm going to solve for Y. How do I do it? 30Y equals 5. I divide by 30. Oh, this is 30 multiplied by Y, right? So I'm dividing by 30, just like Colton did in his head. And he got, what? 5. So there you go. 0, comma, 5. Right? Next, I'm going to let my Y, because my chart tells me to, let my Y equal 0. If my Y is equal to 0, it's 30 times 0. Boom, that's pretty much gone. And I get 10X equals 5. And then I'm going to do what to solve that? Divide again. So X equals 15. And I can do all this in my head. So now all I do is plot these points. So I'm going to plot 0, comma, 5. Did I do that backwards? No, I did not. I totally did. 0, comma, 5. I totally did that backwards. Sorry, I wrote the numbers in on the wrong spots. I know. Why don't you guys correct me?
I thought I was correct.
Did you realize my error? Oh. Jeez. How did I know I was wrong, Colton?
I don't know. Because you looked at it and
Because I looked at it again, I saw my graph and went, wait a second. I couldn't graph that. So 0, comma 15 is way up here. I put a dot. And 5, comma 0 is way over here. I put a dot. Connect them. Okay, at some point, they might ask you, what is the line standing for? What does it mean? So, the line stands for any combination of Blu-ray discs and albums that you can buy. So I want to look at, if I bought 4 Blu-rays, I just follow this up, how many albums could I buy? Well, if I buy 4 of those, then I could buy 3 of these. See? What if I bought 10 albums? Well, then I could buy 2 Blu-rays. Okay? So it tells me any combination of the 2 that I could buy. I can't go past that line. I'm looking right at the line. Yeah. All right. So I'm going to give y'all guys a little bit of time to work.